Okay, I think it's almost time, so let's start. First, thank you for coming this session. And my name is Liang. I'm from virtualization team of SUSE, and today going to do a presentation about run GPU virtualization. So how to run that in SUSE. So okay, it's okay. Yeah. Yeah, for this session, first I'll give you some some background about GPU and virtualization. And then we'll move to focus on the GPU virtualization. We'll see some definition, classification, why we use it, and how we use it. And also I'll give you some critical techniques about GPU virtualization. Okay. Okay. I also ran some demos to show you how to let it run up. But since I couldn't connect to our data center, so I just ran a local GPU virtualization based on my Intel GPU here. Okay, yeah. And after that, we'll see some current status and future to-do things about SUSE and also outside vendor. Last is the QA. So the whole thing, I think it won't last 1 hour long, maybe 40 minutes, but they always for sessions for 1 hour, so we can save some time for that, for your lunch. And also, don't be worried about some techniques here. If you are end user of some big data, machine learning stuff, most times you don't even use all this stuff. That's why we provide them. And yeah, so most you just focus on your environment, setup, and stuff. And for that part, it's pretty straightforward. We are going there. So now let's see some background. GPU. I think we all know GPUs today. And here's just some timeline about GPU. Like from the 80s, there's not a GPU idea, it's just a VGA. And I think earlier than that, there's even no VGA. It's just a CPU doing all this graphic work. And then moved to the 90s, a lot of VGA cards popped up at that time. So many companies, they're coming, they're down, they're go. But anyway, it's quite timed for this kind of VGA cards. But after that, since the 1998-7 here, I want to mention about this part is the 3D acceleration parts. It means for this part, it needs more functions, and it makes the cards so complicated. If you are familiar with all these 3D parts, you know there's a reading process, shading process. I don't know that part. But anyway, it makes the whole unite so complicated. It's so hard to extend it later. And then it comes a unified architecture. It means it uses all the same unite components and make it programmable. In that way, you could implement different functions for your work there. It then suddenly simplifies the whole GPU stuff, and most importantly, it could make for the GPGPU, the general purpose, the data we are using for the computing stuff, it's so easy because there's so many computer processing there, and you just throw to them, and they will run it for you. And that's the main part you need to know, I think. So after that, there's CUDA. Today, all the machine learning stuff, they kind of based on CUDA. Nvidia dominated all this part. But all the others, like AMD, Intel, they're coming, they're catching up. So everything new will happen today. So back to the GPU first, like what do we want it? What can it do? Two things. First, graphic rendering. Maybe you're a gamer and you want a better performance. Also, like today there's the fancy science fiction movies, all the things there, they need a good graphic computer there. And also today there's so much about the gaming, the short video, that kind of stuff. They need a kind of a graphic process too. The other part is the most people cares about is the general compute. You can use for the big data, machine learning, or whatever you call it. I think you guys are expert. I'm not quite. But anyway, for the GPU purpose there, for GPU use, they have a pattern, like they all based on some library. For the graphic, you need to use DirectX from the Windows, OpenGL, or today the Walkman is quite popular. Big data, okay, it's kind of, yeah, that's fine. You need a CUDA from Nvidia, OpenCL, more general, and quite popular from the university research part. So, and I just want to know that, yes, GPU is quite good at general computing. It's very good for machine learning, but it's not the only option. Like you see, for graphic, you can use the CPU to do it. You can use the GPU to do it. For big data, there's the CPU can also do it. I think that's the HPC, the earlier HPC doing there. And GPU shows the super powerful because of its unified architecture there. They put so many computing cores there. And also today there's the FPGA, this new concept, and also different kind of PU stuff, NPU, narrow processing unit, TPU, tensor processing unit, all this stuff they can all do. The main idea is that, so why is really necessary for a big data for your machine learning there? So that's because the data has a pattern for some specific instructions there. And in this time, data means more for your instruction. So they need a totally different architecture. The traditional CPU couldn't satisfy it. And GPU, it happens to be one of it. So far, it's quite good one, but we'll see in the future. Here is a general GPU structure, a modern GPU structure. This is from Nvidia Fermi. So the first look we are seeing is that there are so many theme stuff there. The core, there's so many cores there. That's the unified architecture there. And you can program to them, let them run different tasks there, and you can just through more instruction there. So you can see that it supports MID, multiple instruction, multiple data. Our general is SISD, it's simple instruction, simple data. It's the traditional John von Neumann, if you are familiar. And also it's good for the VLIW, very long instruction word. And this is all data-oriented.
How long is the long instruction?
It's like 128, maybe long. Yeah, maybe longer, but it's actually more good for the SIMD, single instruction, multiple data. That's the best good for that. So it also has some memory here, register, cache, and the GPU memory there. So it basically looks very same as a CPU there. And that's also true. So here, don't be scared by this one. You don't need to, you just need to see that this is how GPU work with the CPU there. It has a channel to communication. It also has the contact switch idea there, like the process contact switch there. Because there's multiple tasks there, you may run multiple things on one CPU. So there will be scheduled stuff there. And also, they have the memory. They use the memory, I/O memory, or the traditional memory, video memory, or host memory for some control commands there. So the whole idea is give you like for this part, you just need to know GPU, what's GPU? GPU could do two things, graphic, big data, machine learning stuff. And it's complicated. And it works as a dependent device to the CPU. And that's all you need. And that's why the device could make it work as working in a virtualization environment. So that's all you need to know. Now let's jump to virtualization, my favorite topic. I'm actually from virtualization team, so this is my day job here. So, and for virtualization, it's quite wide. What's virtualization? It's basically speaking, it's like let you to run multiple VMs in one machine here. You may run dozens, hundreds, thousands if you want. And then you may asking, why? Why should I use it? So this is the reason, kind of. First, it would be more efficient. And there's research showing that for the normal bare metal server there, the usage, the daily usage is only like 10%, 20% general. So basically you waste so many costs there. And but if you using virtualization, it could bump up to 60% and even 80%, 90% for that part. That's really good. And it also makes it security, more security than the traditional. Like sometimes the hacker maybe want to know, they can hack some things for the bare metal stuff, but if in a virtual machine, the normal operation won't work anymore. That's good for the security too. And it's also very good for many things. Like since a machine becomes an application, like a software there, so it's more manageable and more software defined there. The content, you can define a machine, device, network, storage, that's all today, right? And mostly, if even you don't know virtualization, you may heard of cloud today. It's all cloud, not OpenStack and AWS, Microsoft Azure, and Google, a bunch of that part. For all these cloud production, each fundamental infrastructure is virtualization. That's why they could work. So that's kind of importance of virtualization. And also there's so many choices too. Like, if people use it, then more people will going to provide it. That's the marketing. And there will be KVM, kernel virtual machine, and also there's Zen there, Zen from Citrix, and also there's VMware and Hyper-V from Microsoft, and then blah, blah, a bunch of that techniques. So it also shows that it's important. People want to use it somehow. And now we know that there's virtualization. There's a lot of virtualization. So, but from the fundamentally, so how many kind of virtualization there? There's always software way. There's always hardware way. And there's always a hybrid way, combination software and hardware. For software, it's easy to implement. It's basically no extra cost for the hardware. So software engineer could just design it and implement it. And that comes to the QEMU and box here for the emulation. And then, if it's quite good, it's quite popular, the vendors may thinking, I should make it in the hardware. In that case, I could provide more feature, and that's good for me. So then it comes to the hardware win. for the hardware, there's a CPU, CPU and memory and I/O devices. Now see, we see the I/O devices here. So GPU, we just said GPU working as a device for CPU. So this is we are going to talk later in this session. So here is this virtualization. Now we know the GPU, and we also know the virtualization. So what the GPU virtualization then becomes quite straightforward. So basically, we want to run multiple. We want to run multiple GPU for multiple people there, based on one machine, one GPU card. That's the first idea of the GPU virtualization. And since we know that GPU is an I/O device, and virtualization could implement it, so that makes it happen. So now we jump to this GPU virtualization. So still, why? Why? That's because people doing it. Like this is actually for a machine learning data there from the Gartner report. There's a huge market there. 2017, like 145 billion marketing there. Last year, 175. This year, probably going to 200 billion. So why not? So all people want to jump to cut a cake, and I think that's kind of a AMD, Intel, Nvidia, they all provide this kind of implementation. We'll see later. So, and there's a lot of user cases there, like auto drive, medical care, medical area, and finance, like the BU, a BI, business intelligent, and also electronic commerce, like Amazon, eBay. They may want to use for their delivery transport, make it more efficient, or just using on their recommendation algorithms, like they could make their sale more better. Others, like language translation, some other AI stuff. Anyway, it's really need. And since this popular, and there's a lot of companies, they are already working on it. They are providing this exact GPU virtualization service there. If you are working on a machine learning project, you probably know that it's so painful for you set up an environment there to develop things. You need to set up here, set up there. I tried it once. It's just so painful. I gave up somehow. And based on that, there's a lot of company, they are providing this service. Like they have their cloud environment, and they have provided this kind of virtual machine image there. So basically, you create an account there. You log in, you create an instance, then they will boot a VM for you. And in this VM, all the things are set up. There's the GPU there, there's all the libraries there, the framework there. All you need, even there's a Jupyter notebook, some of the development tools there. So you just working on your project, focused on your data directly. So, and all these companies, like the Google, they provided this collaboratory, and there's a company called the Paperspace Gradient, Flowy Hub Workspace, and Lambda GPU, AWS, we know that, GCP, and they provided this VM image. It's not, okay, there's a slit. Yes, a little bit, okay. No, okay, no techniques here. Yeah. Mm-hmm. So, but this could give you idea like what kind of people are really need this. It's typically, it's not for the individual developer, the GPU virtualization. It's more like you have a team, you have a company there, you have a lot of people, but your budget is limited, and you can't provide so many machines, so many GPU cards to them. If you purchase one, you may know that there's this kind of high-end GPU card, they're so expensive. It's like V100 Nvidia, it's like $10,000 or $20,000. That kind. It's expensive than a server there. So in that case, GPU virtualization would be perfect for you. Or maybe sometimes you just have different projects. There, you don't want to set up all your environment every time you're doing that. That's also a good idea for GPU virtualization. You can save all your stuff in one VM, and every time you just boot it, and you just start where you left last time. And again, we are seeing what kind of classification, what kind of types GPU virtualization have. Same as virtualization, there's always software way, hardware way, and both. Software way, for earlier, they're using CPU. CPU trap all the instructions, emulated it, and then send it back. It's easier, it's doable, it's super slow, and quite limited. You don't want it. And maybe you can just use it for some widget stuff, but you don't want to use it for any real work there. And for the specific our GPU, as we know that GPU is so complicated, and they don't allow us to develop on their API directly. They provide libraries for us. So basically, when we're developing for the GPU, we're actually working on the API all these companies provide us. And for that case, you can do API forwarding. Like in the VM, you intercept the API, the real command it's going to do, and then forwarding to the host side directly. And then it's straightforward. It's much better than the CPU way. Only one thing, like if the vendor, they changed their API, it will become a hell here. It's like you don't want to touch it. This is kind of also not a choice for us for machine learning part. And then comes to this I/O virtualization part. Since GPU is a PCIe device for CPU, so we can do it as a device way. So I/O device, we can pass through. We can just pass all this device into a VM, and then we use there for the VM, for all the information you know. This is good in some way, bad also in some way. Good part, you still can save all your setup there. You don't need to go suffer more times. And also you can migrate it from one machine to the other machine, but in a code way. Like you need to shut down your machine, VM, and then move it to another one. But these two machines, they need to have the same GPU cards there. So in that case, it makes work. So good part and bad part is like it only works for the one device and not quite flexible. And then it's the full GPU virtualization. That's actually the topic I mean here. Like we'll see the full GPU virtualization, and just going to that. Also, there's also like a software and hardware hybrid way, parallel virtualization. VirtIO GPU is kind of an option. Like it could support OpenGL 3D, but still not for CUDA OpenCL yet. It's better than the normal way, but still it's ongoing. We'll see in the future. And the GPU part, just like I said, it's good and a little bit bad. And from SUSE, we actually already support it from 12SP2. And Cloud, I think Cloud SOC 8 is also support it now. And yeah, one thing I left, it have a good performance. It could go to the 95 and 97. It's, yeah, I think you may lose some performance, but like I said, you got some convenient, like more easier to manage it. You can save your environment. So that's good, and only for one VM, lack of flexibility. This is the true rule today for GPU virtualization. So back to the early question, we are seeing like what do you want to get from GPU virtualization? Like I said, I have 8 people and me, and I want them all work on this machine learning project. So I needed to give them each one a developing environment. And I don't want them feel they're working on something else. Like it should be working on a real machine. Like you can install driver directly, and you can, after you install it, you could run all the library, all the framework you want. You can want to run OpenCL, fine, CUDA, good. And you don't want to lose so much performance. Like you don't want super slow. Like they need a couple days for one work. So that's what the full GPU virtualization for. And for doing that, couple things you need to keep in mind. So for model people, so I need to split my device into different pieces. I need to be fair. I don't, maybe you can, yeah, not that fair. Like you really like your people, you can give her better, you can give this guy a better configuration. That's later talking. But generally they're fair. They're using time slice to, like they give you different PCs, and each PCs will, once it's their turn, they will took all the GPU for their work. So that's the split doing. And what's the difference is that the frame buffer memory or the video memory we are talking here. You really like the guy, you give her or him 4 GB, normally 2 GB. And you also want to isolate it well. Like you don't want to this guy mess up with the other person. Like they need to do work totally independent. And also for all these 2 things, you want to make it work, you need a better schedule algorithms there. And there's different ways because there's different implementation. AMD, they have a hardware implementation, like we said. And Nvidia and Intel, because they don't, the patent issue, something, they can't do that. So they developed a software way to do this part. But it's still good. It's not like the normal software. It's still pretty fast. We're good there. So, and now you see, this is the goals we are needed to conquer to make it work for you. And yes, this is the implication. Like Nvidia, they have called the grid, and Intel, they have this GVTG. AMD, they have GIM. And for this part, Intel, they already merged to the kernel, so it's upstream there. Nvidia, we know they're not open source. You can use them, but you still need to buy license. You need to register your license first, and then install the management tool from them, and then run your case. AMD is not on upstream yet. It's open source, but not merged to upstream yet. You can check from the GitHub. And since it uses the hardware way, it's quite simple. We'll see that too later. And question?
AMD has I/O review support, it says there. But I was under the impression that I/O review is something built on the motherboard, meaning on the system, not so much on the graphics card.
I/O, you mean which one?
That's it.
Oh, I/O, I mean, okay. IOMMU.
This is more a function of the motherboard, meaning on the system where the cards are built, not so much a function of the card.
Yes, yes. It's like the host, it's kind of a host function. They can help the I/O virtualization, but it's not for the GPU itself. It helps them. And yeah, I'll go there later. There's more details. And I just want to show you the difference between all these three vendors. Intel, we know that it's just an integrated graphic card. And you may buy it work, but there's no specific memory for them. You need to share with your main memory. And AMD, because it's hardware, it has this IMU support. Like they could use some benefit provided by the IMU, makes it more straightforward, more easier to set up, and more security. And that's good. But also, only Nvidia could support CUDA, because CUDA is released by Nvidia there. So still Nvidia dominates all this market here, and that's yeah. And this is some of the production that for there to do this kind of work. Nvidia, the new one, Tesla series, they could all support this function from the Maxwell earlier Pascal and Water V100 today. They all could support this GPU virtualization. And there's also some earlier called the Grid, Kepler, Key1, Key2. That's only for VDI, actually. It's for the graphic part, display part, for their production. It's not good for GPU yet. And AMD, they announced, I think 3 years ago, they announced this FirePro series S9150, and by 2, you can run like 8 VMs and 16 VMs at the same time. And they also like their most production is called this Raiden Instinct production. This is their fixed production now. It's mostly for computing. Earlier MI6, quite interesting. CIA maybe, MI8 and MI25, and today they are going to release MI50, 60, and they have MI100 in the future. Like I said, only Nvidia could support CUDA, and CUDA is so desirable. AMD, they provide this HIP architecture. It's like CUDA and HIP and OpenCL. Like there's a translation layer here. So they kept the CUDA API there, translated to the OpenCL, and then once finished the computation, and then send it to back. They also have new plans for that, but yes, you see they're trying to get into the machine learning part. And Intel from the Haswell and Broadwell, Skylake, and also because this part is so important today, they are going to release their dedicated GPU next year, hope so. But they announced that already, and yeah. So that's it. Now we see that we know the full GPU virtualization. Like I want a lot of people to using one machine, one GPU, but everyone works happily. And also I know that I have choice. I can run the GPU pass-through. It's workable. It has performance. Some scenario, you think about it. Also, you can use the full GPU virtualization. You know that all the vendors, they provide the solution for you. So you just need to considering your user case. Like you choose the different production and the different implementation there. So you have a choice, and they're all there. And now we just take a quick look about the real part of the GPU virtualization. We are just unveil the mystery of it. Like, you don't need to fully understand, just good to be known, right? Like for your day job, like. And yeah, so like I said, there's a hardware way and a software way. And AMD implemented the hardware way. That's the SRO way, single root I/O virtualization. I think it's more popular from the network device, as you know. And also there's a software way for Nvidia and Intel. Normally software way is super slow, but not for this case. They did a lot of optimization experiments, and they make it quite good and more flexible. So, and actually they're pretty cool. This is kind of why GPU virtualization more doable, like you have more performance. Because during some Squirrel Research, university research, they found that when you're loading a GPU task and running them, most of the time is on two things, the command buffer and the frame buffer. So it looks like most of the time they're working on transferring data. So if you could map this address to the VM from the host to VM, you can save this operation. You don't need to move them. Then you don't need to think about this cost here. The frame buffer is basically the graphic data for your host, for your like the CPU part, the main memory, and your VGA. Like Linux kernel will open frame buffer memory there, and everything. They will generate the new picture there, and then this memory will project on your monitor. So you could all track it from that part. And the command, it's like, since you know that the GPU is so complicated, it's kind of the same as the CPU. It has a fully function there. It has their operation, computing core, control part, cache, memory. So this is for their command. It's still kind of data, but only instruction data. So you can still like map them, like pass through, but only pass through this critical part to your VM. In that case, you will just waste very minimal, like 5% or 10% there. But instead, you are gaining the multiplex capability, and it's more easier, like I said, more easier to management, and more easier. It's more security there, and so it's a trade-off. It totally depends on your scenario there. And this is for this part, like we needed to put some host sources to the get sources, host resource to the guest resource. So you basically need these two fundamental techniques there, IOMMU and VFIO. This is IOMMU is just he said that it's a hardware implementation from the motherboard. Like it could give you ability. It's like the MMU. Like we know that there's a physical memory and the virtual memory. All our application is actually running on the virtual memory. And the MMU will translate this VM to the physical memory. Same idea for IOMMU is for the I/O address is only the device visible I/O address. It could map from the VM to PM. Normally, the virtual memory is the same as the CPU memory, so you don't need to think about it. Anyway, this is give you the possibility to move all your stuff to the user space level. That's good, because if you device any device driver, it means you need to deal with the kernel module. And it's kind of a kernel space. And sometimes if you did something wrong, it will cross your whole machine there. But if it's in a user space, you just hang out one process there. You can just kill it from the kernel. You're still OK for your machine. That's good part too. And also, it has isolated this, because it does a lot of remapping, the normal attack won't work for it, more security. VFIO is more like a software implementation. It's like make all this, it's based on the IO MMU. It makes more programmable. It works quite well for the VM, but you can also don't use it for the virtualization. Like some DBDK, like you can just assign a VFIO driver for it. And that's these two parts. So this is basically how you move your work from the host side to a user space guest level. And now comes to these two implementation, SRIOV, hardware V, and mediated software V. Like SROV hardware, AMD, it's very good performance. It's the best case could go to 97%. And MDV software V for Intel and Nvidia, it's not that bad. You could still got 80 or even 90 sometimes. Because the main part, the command buffer and the frame buffer, the two parts already mapped in your VM. And for SROV, because from the hardware side, the host side, it provides a whole bus slot function number, which means if you run LSPCI, you will see the VF listing there. So in that way, you can just pass. It's same as pass-through once you set up. And it's quite easy, even easy for their implementation. And also because this IOMMU stuff, the command, the IO command, the address is, you can run the address directly. And but for the MDV, mediated device, there's a translation part. Like you need to save a table for this translation. Other than that, they're all time slice. They are using this idea. Just you have one time slice, he has one time slice, she has one time slice. You just switch. And so yeah. Also, for SRV AMD, you could use VFIO directly, but MDV, you need to use VFIO-MDV. It's kind of a tweak for that. So in case it could manage it from the software level. And also like, because it's not an independent device for the host. It's like if you run LSPCI, you couldn't find any information. In that case, you need to give it an ID. So here they're using UUID to identify the device. We are just going there. So this is the software view. And so far we have our subsystem in kernel. Okay. And yeah, host side, the vendor provided their driver and then register there. And the MDV side, the VF side, and you also register a driver. This registers a device that registers a driver on their bus. So it works happily for your VM. And also there's some other interface for you to do management, like you need to create something and you need to destroy it after you use. Not quite convenient, but yeah, it's okay. So this is how it works. Like I said, initialize, register first, and then user needed to create this device, and then just attach to VM. This is how VM part works. Use a file description. Okay. Anyway, you just need to know that they could do it. And yeah, that's it. So here, demo. So now just going to the part we really care about, or you may get your hands on or not. But anyway, you keep this in your head. For GPU virtualization working, there's 3 different kind of work. For the host side, and there's a hypervisor side, and guest side. Oh no. There's the bottom line here is called the development environment setup. Most time, this is the only thing you're working on, and you can't see it. So what you see here, you probably never do it. And anyway, so like for the host side, it's you need to enable it from the BIOS. Normally, I think it's by default enabled by default already. And kernel side, like if you want to use it, this is something you need to know. Like it has some requirement for software and hardware. Software, if you are using AMD for Nvidia and Intel, make sure the kernel is newer than 410. Yeah, and translated to SUSE Linux, it's like 12SP4 or 315, that side. But if you are using SROV, so it's 4.4 for AMD part. It's kind of since if it's newer than 12SP3, you are good. And but even for that GPU pass-through case, you can start from I think I said it's like 12SP2, so it's more flexible for using. And all of them needed to install a management driver from the host side. But Intel, because it's already merged to the kernel, so you don't need to do anything about it. And Nvidia, sometimes you need to run manually. We can also provide some package there. You can just zipper install it. That's it. So not difficult. Just you need remember there's a step here. And you need to create this vGPU device. For AMD, you don't need to do it. It's already that. It's only for the Intel and Nvidia. You need to pass that UUID, give it its unique ID for the further usage. Hypervisor, here I'm using QVM, QEMU, and LibreWord. Also, I think VMware, then they all support it. They all support it already, so no worry. One thing I want to mention is that you don't use CBOS anymore. You need to use OVMF, UEFI for that part to make it good. And also, LibreWord already provides this life cycle management, which means when you start it, running it, and then you stop it. So nothing. And then attach to the VM. Depends on you're using QEMU command line or LibreWord. So I'll show you that. It's simple, straightforward. And same as the management driver, all of them we are using a special guest driver here, guest kernel driver. Again, Intel already merged it to there, so you don't need to do anything. It will run there. Nvidia, you need to install that again from your guest VM side. But it's same as the normal GPU driver, no big difference. And then couldn't see is to set up your environment. Or you can set up them in advance. In other words, you can just give, you don't need a new employee training for that part. Or you don't want to do it, you can jump to that company's, said that you can, that companies, they're providing all this site, you just pay for it, for test. But I think we are going to provide a similar production in the future. Yeah. Now let's show how to set up. 3-level host, hypervisor, guest. But for host side, you just need this command line from the boot command line. Enable it for your kernel. So enable GVT. That's the things you need to do for the host. And then you will see this MDV support device under your sys file system there. It has 2 types here, v5.4, v5.8. And then you need to use this UID gen to generate your UID. And then echo it to this create part. And then you'll create your own device there. There's a vGPU there. Yeah, we're also working on this kind of make it, there's tools for it to make it more simple. And this is for QEMU. You just add these 3 lines there. Since you are using vGPU, you don't use the default VGA anymore. Off the graphic and enable the GL. And then, so let's see, just to show you this case. For saving time, so I don't enable the boot command line and anymore. But if you're interested, I can show you that. It's here. Where is it? Yeah, okay. It's kind of different resolution for me here. So this is all you needed to do. And yeah, after that, you'll see here. Let's get into one device here. Available, it's like how many instances, how many vGPUs you can create here. Oh, maybe yeah, from here. Available, that instance, that's how many capability, how many you can do. And echo your UUID to the create. And then once done, once you create that, it will create in your device here. I'll show that, but here. You see, this is only support 1. And this is a demo here. I'm going to, for saving time, I'm also here. Like you see, I just generate this UUID and pass it, echo this, and pass it to here. To the device mode, I choose v5.4 here, and then create. And then command line, there's this 3 line here, graphic, and GR on, and this device here, this 3 line. So let's see. First, it will running in your terminal because it's not loaded the driver yet. But once loaded the driver, here we are. This is the real. So you see. Oh, okay. Oh. Yeah. Now it's actually booting this VM with the vGPU you're using. Come on. it's because, okay. No, it's the resolution. I can't see. Oh, that's awful. Okay. Here. I just saw the turn. Yeah, that's. I didn't give it too much resources there, so. You see here, VGA is already used this Intel card. But if you are using the normal way, it will choose a VGA there. But anyway, yeah, similar for, let's go back to the, it's kind of similar for all this part, Nvidia and AMD. AMD is more easier, but yeah, you see, it's straightforward, not so much configuration there, and you can do it like here. You can, this libboard, okay, you couldn't see either. There's just a simple lens there. Okay, last, we are just to see the current status. We use all techniques ready for them. And it's just some business stuff. We're not official support it. So if you guys want to do it, if found some issues, just file a bug report assigned to me. I would be glad to discuss with you guys. And we have plans for the cloud. And we also have some discuss with the container side, maybe how to use them for the container virtualization. And outside, it's also keep going. There's a remote display IOMMU line migration. I think this is all done. Schedule algorithm still need working on, and other things like the GPU for container, and also some FPGA, TPU, NPU, if it is possible for virtualization either. That's what we are working on now. So that's all. Sorry, I think the time is still quite tight. Any questions? Okay, thank you so much for your time.